Good afternoon all. Today I have uploaded counters notes. So we all will be clarifying our doubts in this video. If you have any doubt, I hope it will be cleared by this video. Counter is a sequential circuit which is used to count like 0, 1, 2, 3 and so on. Okay. We have different types of counters, asynchronous and synchronous. First of all, asynchronous counter means that clock will be given to only first flip-flop A, as you all can see, this is a clock. And output of this flip-flop A, that is QA, will be acting as a clock for flip-flop B. Okay? This is a flip-flop A and this is a flip-flop B. Notice that flip-flop A input is TA. TA means this is a toggle type of a flip-flop, toggle A. And flip-flop B again input is toggle B. Okay. So as I told you in the past lectures that when toggle is 1, then output, if previously output is 0, it will change to 1. If again toggle is 1, if previously output was 1, then presently it will change to 0. Keep this thing in your mind. Okay. Now, again I want to clarify what is asynchronous. Asynchronous means that clock will be given to only first flip-flop and output of this flip-flop will be considered as the clock for this another flip-flop. Okay. Now, synchronous counter. Synchronous counter means that clock signal will be given to all the flip-flops simultaneously, as you can see here. And input will be given to only first flip-flop. And output of this flip-flop, that is QA, will be acting as the input for another flip-flop. Suppose if it is flip-flop A, if it is flip-flop B, then clock will be given to both the flip-flops simultaneously. Mark this word simultaneously. But input is given to only first flip-flop and output of this first flip-flop will be acting as a TB input for flip-flop B. Okay? But class, in today's lecture, we'll be considering only the asynchronous counters. Okay? So keep this thing in your mind. Okay. Now let us start with the example number 1, that is design of 2-bit asynchronous counter. Again I have drawn the same diagram. Clock is given to only first flip-flop. Output of this flip-flop is acting as a clock for the another flip-flop. Okay, keep this thing in your mind. Class, you must have noticed that I have drawn clock diagram like this, like bubble and this. This bubble indicates negative clock. Okay. So this is a negative clock. If I draw like this with no bubble, it will be a positive clock. Keep this thing in your mind. Okay. So class, notice that this flip-flop is again negative edge triggered. Negative. And this flip-flop is also negative edge triggered. Okay. Now, let us understand the operation of the counter. Class, suppose that if QA initially let both QA and QB equals to 0, 0. Hence, first output of the counter is QB, QA. All of you keep the sequence in your mind. QB will be MSB, QA will be LSB. QB is your MSB and QA is your LSB. Okay, QA is your LSB. Now, initially when counter is just started, suppose both the flip-flops are reset. Reset means QB is 0, QA is also 0. So keep this box in your mind, as I have given the name to this box as box 1. Okay, keep this box 1 output, that is 0, 0 in your mind. Now we are starting the operation. Okay.